Hi everyone, today we're going over lesson 7.6, which is solving exponential and log equations. We're going to start with exponential equations, and one important thing to keep in mind is something called the property of equality. So that says that if we have a base, in this case a 3, raised to some exponent, and on the other side we also have that same base. So it doesn't have to be a 3, it can be anything as long as these are the same, raised to another exponent, then the only way that that can be true is if our exponents are also equal. So we can use this property of equality to solve some exponential equations if we have the same base or we can create the same base. So let's take a look at what we mean by that. I have 5 raised to the 2x plus 4 power, and that's equal to 5 raised to the 5x minus 8. Well, I notice right away that my bases are the same. I have a base of 5. So in effect, these 5's will go away and I can set exponent equal to exponent. 2x plus 4 is equal to 5x minus 8. I'm going to move the 2x over here and the negative 8 over here. In other words, I want to get all of my variables on one side, so I'm going to move the 2x over by subtracting it, leaving me with 3x. I'm going to take the negative 8 and move it to the left by adding, and that'll give me 12. And then I can solve for x by just dividing by 3, and x is equal to 4. So it becomes a fairly simple algebra equation once we are able to eliminate the exponent bases and just solve for exponent equal to exponent. Let's look at this next one. So I have 4 raised to the 2x minus 1 power and 8 raised to the x plus 2 power. Well, I know that 4 and 8 have a 4 in common, but I can't rewrite 8 as 4 raised to a power. However, what I can do is rewrite both of these with a base of 2, because 4 can be rewritten as 2 raised to the second power, and 8 can be rewritten as 2 raised to the third power. Now, 2 raised to the second power replace the 4, but we still have that 2x minus 1 as additional exponent. Remember, when you have a power raised to another power, they simply multiply. And so the 3 is going to get multiplied by my original exponent of x plus 2 as well. All right, now that I have the same base of 2, I can get rid of those and say exponent equals exponent. 2 times 2x minus 1 is equal to 3 times x plus 2. Distributing that to get rid of parentheses, I'll be left with 4x minus 2 is equal to 3x plus 6. And now let's solve. I'm going to move 3x over here. When I subtract 3x, I'm going to be left with x. I want to take the negative 2 and move it to this side. When I add 2 to both sides, I'm going to get 6 plus 2, or 8.